Just in the meantime, please rename your username again so that it incorporates your student ID and your student ID and your name, because I'll be taking the attendance towards the end, right? Okay. So, anyways, let's start, right? So where we stopped is that okay, we stopped over here. So it says, so we have two sequences of length L and P, right? So in order to compute secular convolution, we know that two sequences are of different lengths, isn't it? Like like someone just queried, what we have what if we have two different sequences of different lengths, right? So what do we do in that particular case, right? So let's consider, going back to this particular sequence, let's just consider this of size L, right? And then this sequence as size P, right? And we are told, right? We are told, let's just reduce this to just 3, right? Let's just consider the L value over here is equal to 3. We have a sequence of 1, 2, and 3, just 1, 2, and 3, not 4, right? Just 1, 2, and 3. So the length of this sequence is equal to 3, isn't it? And the P value for this sequence will be 5, 6, 7, and 8. That is equal to 8, right? Now, if the sum of these, if we are told to find endpoint convolution, right? We are told to find endpoint secular convolution of these two sequences, right? Then the length of the sequence will be, the length of the, what do you say? If n is greater than equal to, if the endpoint secular convolution that we are told to find, this is n, right? The endpoint secular convolution that we are told to find, that is represented by capital N, is greater than equal to L plus P minus 1, right? L plus P minus 1, then what happens is that, right? If n is greater than equal to L plus P minus 1, what happens is that the secular convolution of this many endpoints will start to give me a linear convolution, right? Let's say in this particular case, if n is greater than equal to 3 plus 8, sorry. Just pardon me. My p value was supposed to be of size 4. Sorry about that, right? So in that particular case, it would be 3 plus 4 minus 1. If n is greater than equal to 3 plus 4, that is going to give me 7. Minus 1 is going to give me 6. If n is greater than equal to 6, if we are told to find the endpoint 6 endpoint secular convolution of these two sequences, right? We already know that these sequences are just short of these 6 points, isn't it? So what happens is that we'll need to increase this sequence to 6 what do you say 6 elements, isn't it? So in that particular case, in order to increase this sequence to 6 elements, what we'll need to do is to pad it with 0. So this sequence has to increase by 1, 2, 3, right? And we add 3 zeros in order to make this element, this L, equal to 6. The same goes for the bottom sequence. It is at the moment short, right? Short of this number, that is 6. It is not having 6 elements in this, so we pad it with 2 more zeros in order to make it 6. And then if we compute the secular convolution of that, the 6-point secular convolution of these two sequences, right? Of these two sequences, it is going to give me linear convolution, right? If n is either greater than equal to 6 for these two sequences, right, we are going to get a linear convolution. Is that clear with everyone? You getting what I mean? Right? Remember, if the sequence is, if we are told to find a n-point secular convolution where the n is greater than the size of the sequence, we pair it with 0. Always remember that, right? So if in either case, if n is greater than equal to L plus P minus 1, it is going to result into a linear convolution. So in this particular case, the example that I just showed you, right? If we had two sequences of size 3 and 4, and we are told to find n-point circular convolution where the n is greater than equal to 6, in that particular case, we are going to get the linear convolution, right? Okay. N will be stated in the question, but it is greater. Yeah, n is always going to be stated in the question, right? If it is regardless of this, right? N could be any numbers. I mean, it is not always fixed, but usually what happens, we are given two sequences, and if n is not given, and it just states to find the secular convolution, we check the sequences. If both the sequences are of that many size, right? So we just use that. I mean, in this particular case, the example that I earlier used, right? It was of size 4 and 4, isn't it? Both the sequences were of size 4. So in that particular case, our n would have been 4. Is that okay? We use size 4. If n is not given, if one of the sequence is greater than the other sequence, what do? We increase the size of the smaller sequence, right? The sequence which has less elements compared to the other one. This is when the n is not stated, right? So when n is not stated, if the size of one sequence is greater than the other one, you increase the shorter sequence to the size of the other sequence, which is having more elements, right? We paired the other sequence with zeros. It is always a practice. We do not truncate a sequence, right? We either paired it. Yes, all so for discussion, both functions start from. Yes, it is always going to give you a starting point that is always going to be either this one or this one. Regardless of that, don't worry, as long as your values are there, that is more important, right? No one actually worries about whether you are initially giving y of 0 correctly or not, right? As long as you're getting the correct solutions, right? But still, if you have to find y of 0, what happens is it could either start at any point in the sequence, right? So your x1 of 0 could also start from here as well, right? So just be careful where it starts. It will be highlighted in your sequence. Always remember, if y2 of x1 of 0 starts over here and x2 of 0 starts over here, the value, right? When we're shifting, when these two numbers align, right? When these two numbers align, that is where we are going to get the convoluted value, the y of 0 value, right? Okay. When these two zeros align, right? Of these two functions, the zeros of these two functions align, will going to give me the 0 of the convolution function. Okay. If you have any other queries right now, if you are still confused, please just drop an email so like no, I can personally explain you what is going on and what is not, because some students might understand, some might not understand, and in the process of explaining one student, I might disturb the understanding of the other student, right? So I don't want to do that much of here right now, because this is something that I want to keep uniform to the other students as well. So if you have any other queries apart from this, I'll wait out, right? Whether it's worth discussing in the class, or whether to explain it to you through email or through other means, right? So all of you clear if we have two sequence of different lengths and we are told to find the circular convolution of it, we do not truncate the greater sequence. We pair the shorter sequence with zeros in order to make it equivalent to the other sequence. And then we compute the circular convolution. Just in case, if n is given, whereby, let's say we are given the capital N as 3, and if the sequence length is of size 4 or 5, if the sequence is greater than the capital N that is given, then only you truncate. Otherwise, you don't truncate, okay? Anyone has any questions regarding that? Is everyone fine right now? Okay, great. Now, there's some other points over here. These are not that important, but yet I suggest you guys just keep in mind, because we are not going to, I mean, I don't think your correspondent will be that much interested in this. If n is less than L plus B minus 1, like I said, L is the size of one sequence, B is the size of the other sequence, and n is the n point circular convolution, right? So if we are told to calculate n point where n is less than L plus B minus 1, then the circular convolution of sequences is a time aliased version of the linear convolution of the sequence. Basically, what happens is you have a set of you have a set of linear convolution. What happens is just it is being overlapped, right? The linear convolution. Let's say you have 5 points in a linear convolution. So when it aliases, you are basically taking four points of that in a circular convolution, and the 5th point is overlapped into another part, right? So you can use the textbook to better understand this, right? Since we are also running out of time, but I believe you guys have the textbook, so you can better understand this part, right? The upper two properties are okay. So these are just the properties of circular and linear convolution and aliasing properties of that, right? Apart from that, I believe you guys have learned about overlap. Wait, there's an overlap add method, and there's an overlap. What do you say? There's an overlap save method, right? Those two methods have been clearly. I think Dr. Asif has provided you with enough resources. There's one video that is also uploaded on your Moodle. Please follow through that. This is because if you need to find a, what do you say? If you need to take advantage of a DFT sequence, right? If you need to take advantage of a DFT sequence, so what you need to do is to, as all of you know, that a DFT sequence is of a finite value, right? When you are computing a DFT of a particular sequence, that particular sequence has to be a finite value. So when in real life, when we have a sequence, we do not know whether the sequence is going to be of this length, that length, whatever, right? Blah, blah, blah. So it's just basically, let's say it could have been a function, it can be an infinite function, it could be just a normal function, right? We are not sure whether it's finite or infinite. So in that particular scenario, what happens is that when we are using a DFT, we have a system of let's say with a function h omega, right? And that particular that particular system will only be able to take a certain number of data sequence one at a time, right? So in that particular case, in order to take advantage of DFT, we need to break the larger sequence into smaller portions in order to compute the linear convolution of the whole system, isn't it? So in order to compute the linear convolution, right, and to take advantage of the DFT method, we use the overlap save method and the overlap add method to calculate the linear convolution of that system, right? Okay, I think you guys will get a much more fair idea when you go through the notes that is given there, right? It is explained in much more detail. So please go over that, right? So this was for regarding circular convolution and linear convolution so far. Okay, everyone is okay with circular convolution now, right? I believe no one should be getting it wrong now. The only part will be tricky is when you are given functions. When you are given functions, you have to be careful. All this while, I've shown you the discrete methods. Why I've shown you the discrete method, it is just to make you familiar with the other what do you say? This is to get you familiarized with the other methods, right? When you are using this a defined sequences, it is much more easier to follow. If I had given you sine pi upon 2n, that would have been much more complicated because you had to find those n values, right? You have to determine those n values, and then you have to compute the secular conclusions of that. So that becomes a little bit tricky. What you say? A little bit tricky, right? So that would deferred. I mean, what do you say? It would defy the purpose of explaining you all these three. What do you say? All these three methods, right? This way you can verify that all three methods are going to give you the same solution, right? That was my objective, to show you that all three methods are going to give you the exact solutions, right? Okay, and also remember that this matrix form method is only going to be working when you are having a defined sequences, right? A sequence which is defined. Let's say if you're given sine pi upon 2n, in that particular case, you have to evaluate for each point in that particular in that particular equation, and then you have to fill this particular matrix and then evaluate it, right? Okay, anyways, so this is regarding this week's remedial. So please do let me know, just go over your tutorial questions and let me know next week, Wednesday, or before that, whenever you find the problem, you just let me know. We will be explaining that or we will be going in depth in the next remedial session. Okay, is that fine? Everyone is okay with it? So let me just take your attendance. If you have any queries, please just write it down there. In the meantime, I'll just take your attendance. Okay, great. So I'll just take the attendance quickly. Okay, great. So anyone has any questions or anything that you want to tell me about? Or we end this session right over here? Set. Week 9's tutorial solution, I have already given it out to the students yesterday. So I'm not I'm not authorized to actually handle all the model documents. So that is going to come through Dr. Asaf. But in the meanwhile, I had given it out to the students of yesterday's session, right? So you can download it just in case if you haven't got the solution. You can ask the students, they'll pass you the solutions. There's 3 files actually. So those 3 files have slightly different variations of the solutions. So you can use that, right? Okay. Okay, so we'll end this session over here. All right, so have a nice day. So see you next week.